So in this video, I'm going to do a few extra problems dealing with conservation of energy, and it will add in a little bit from work as well. So the first one is a bow is pulled back 0.5 meters with a force of 900 newtons. How much work was done to pull the bow back? Well, back in the work video, we said that work is equal to force times distance. So work will be the force, which is measured in newtons, so 900, times the distance, which is measured in meters. And so we get a work of 450 joules. How much potential energy does the bow now possess? Well, we discussed that the amount of work done is how much energy is transferred to the object. So if we do 500 or 450 joules of work on the bow to pull the arrow back, then the arrow will possess the same amount of potential energy as the work done. When released, how much kinetic energy will the arrow have? Well, whenever it's let go, all of this potential energy will then be transferred to kinetic energy. So that's because of the conservation of energy. So kinetic energy, when it's released, will be equal to the potential energy, which means that kinetic energy, when it's released, will be 450 joules of kinetic energy. So then it says, if the arrow has a mass of 0.02 kilograms, how fast is it moving when released? Well, if we know kinetic energy, we can find how fast using the kinetic energy equation. So KE equals 1/2 mv squared. Our kinetic energy is 450 joules. We have 1/2 times m, where the mass is 0.02, and we're solving for the velocity. So what we need to do, first we can combine these two, right? So 450 equals 0.01, half of 0.02 is 0.01, times v squared. I'm going to scroll here. So now we divide by 0.01, and we're left with v squared on this side, and we're left with 45,000 on this side. Now to find v, we take the square root of both sides, and we get 212.1 meters per second. So arrows can move extremely fast. All right, so one more example using all of this combination of conservation of energy. A 10 kilogram box is lifted 5 meters. How much potential energy does it possess? So for this, we'll need our potential energy equation. So mgh. So potential energy equal to mass. Mass is in kilograms. So 10 times g, which is 9.8, times h, which is measured in meters. The type of distance, just vertical. So then 10 times 9.8 times 5 gives us 490 joules of potential energy. If it were lifted to twice the height, so twice the height. Notice this does not have any units, so this is a factor question. So we start with the original, change or circle what changes, twice the height, so this changes. What would the new potential energy be? So potential energy is changing. These do not. So the change in potential energy is equal to the change in height. Twice is 2. So potential energy will change by twice as well. So the new potential energy is equal to the factor times the original, which will give us 980 joules of potential energy. How much kinetic energy would the box have when it hits the ground at the new height? So again, kinetic energy when it hits the ground will be equal to the potential energy it had at the beginning. So if we started with 980 joules of potential energy at this new height, then we will have 980 joules of kinetic energy when it hits the ground. How fast will it be going when it hit at the new kinetic energy? So that will be our kinetic energy equation, 1/2 mv squared. So 980 equals 1/2 the mass of the object, since it's the box still, will be 10 times v squared. So we have 980. Half of 10 is 5 times v squared. Divide by 5. So then we're left with v squared equals 196. And then to find v, we take the square root of both sides. And we get 14 meters per second. If the box were lifted to a height where it hit with 4 times the speed of the original height, how much more kinetic energy would it have? So 4 times the speed implies it is a factor question. So speed, kinetic energy, we need to start with the kinetic energy equation. 1/2 mv squared. We are changing the speed. So this changes and the kinetic energy will change. This does not change, this does not change. You only keep what's circled. So the change in kinetic energy is equal to the change in the speed squared. If it's 4 times the speed, then it'll be 4 squared, which is 16 times. So if we quadruple the speed, the kinetic energy will go up by 16 times, so a factor 16. How much more potential energy will it have before it's dropped? Well, again, just like up here, kinetic energy is equal to potential energy. The potential energy at the top is equal to the kinetic energy at the bottom. So then potential energy will also change by 16 times.